Assalamualaikum and good day. Today I would like to presenting my PSM1 the panel ES Ahmad Zubir bin Jamil and NCR Samuel Abdul Rahman. Before we get started, I would like to introduce myself. My name is Khairul Shahfiq bin ISMAIL. I'm from the Faculty of Electrical and Electronic Engineering Technology, and I'm also from the course DEEY. For this PSM, I'm under the supervision of TS Dr. Zulkifli Ibrahim. The title for my PSM is Short Circuit Force Winding by different copper strand and tensile strand using Ansoff Maxwell. Before we go deeper, this is the content that will be in my slide. That is introduction, statement, objective, methodology, expected result, and conclusion. Before that, I would like to tell you about the transformer. As we know, in general, transformer consists of primary and secondary winding, through which constant power is induced by current and voltage transformation. Then, the primary winding current will flow. Primary winding current flow will induce magnetic field that will connect with the secondary winding. Consequently, the electromagnetic within the transformer generate the electromagnetic field. However, this electromagnetic field will produce force within magnetism law in the transformer winding. The force that may be produced is the short circuit force. The short circuit force occurrence in transformer winding can cause high current circumstance. Okay, because of this force in the winding, it will lead to the failure of the attribute of mechanical damage, and then the electromagnetic force can cause the interaction of the winding current magnetic flux to be failure. Okay. Then in this short circuit force, there is two things that we need to know. First is the axial force. Axial force is tend to bend the conductor in axial direction, and their sum act on the coil clamping ring. That's mean the axial force, it tends to cause contraction or expansion, so it will change the height of the winding. It will be make the winding to be unequally distributed between inner and outer winding. Okay, and then for axial force, it tend to crush inner winding against the core and burst the outer winding. This radial force will act as compressive force on inner winding and as tensile force on the outer winding. That means it will be affect the winding along the transformer coil. Okay. Problem statement. As for problem statement for this project is the first problem statement is the transformer coil are subject to tremendous force under short circuit condition because current may be of the order of 100 or 1000 of amperes. Then the cost of radial force that outwork on the outer coil, putting tensile stress on the conductor. The third point is another force that happen in axial. which the inner and outer winding are subjected to axial force. Lastly, we want to know how the size of copper strand and axial spacing can give effect to short circuit current transformer. The third one is the objective. The first objective for the project is to investigate the transformer ability to withstand short circuit. Secondly, it would like to analyze the transformer capability to withstand reduced axial and radial force due to the rise of magnetic flux from short circuit events. And then, lastly, it is to investigate the effect of different size of copper strand and axial spacer based on calculation. There is 4 scopes that will be done for this research. The first scope is this project is more to the research and simulation for the final result, because it is hard to get the real transformer to do the research. The second point is we have to read more journal and article from the previous project that related to this project, so that we can get more understanding on how the short circuit force on the winding transformer works. Other than that, the information also can be get from another platform like Google and YouTube. Lastly, for the simulation, we will use the soft network expectation to construct the short circuit transformer, and from there we can get the magnetic flux, the short circuit waveform, and the electromagnetic force. Okay, for the methodology, this is the process on how this project is working. At first, we will study the topic and state the objective of the problem statement that been said earlier. And secondly, we will find the related article for the topic. After that, we will study the article for the literature review. When we get more understanding of the study, we will start to design the transformer prototype for simulation until the system is working, and then we will do a calculation for different copper strand and axial spacer. The expected result. There is 3 types of expected result that we will get from this. The first result is short circuit system. This is the short circuit waveform that we expected to be get when we run the simulation. If a short circuit the current developed, the transformer may be damaged, and then the short circuit condition was used for the electromagnetic analysis, which result in the short circuit waveform. This is the waveform that we said before. And the second expected result is the leakage flux density. This is the leakage flux for the normal transformer, where the magnetic flux density is spread evenly over the core. You can see the flux is distributed equally. Compared to this, when there is a transient current or the short circuit force in this, the flux in the core is partially saturated in some area, and leakage is visible. This is part of the leakage that is said around these transformers. Okay, for the last expected result is the electromagnetic force. As we know, in the winding of the power transformer, the electromagnetic force is calculated by using the leakage and transient current. Therefore, for the high voltage winding radial force, the result that we expected is that each conductor cell have a positive direction, which is oriented in the radial direction. That's mean the external winding force are exerted in the direction of the tensile. And as for the low voltage radio force, it is directed in the negative direction to the core at the low voltage winding side. Thirdly, for the high voltage axial force, for the axial force, we know that each conductor has an influence on each other. Therefore, when the winding on the upper half have an axial force, the winding layer will be in the downward direction, and when the lower half winding have an axial force, the winding will be in the upward direction. Uh, as for low voltage axial force, it will be completely opposite to what happened in the high voltage axial force, which is when the winding on the upper half happen to have axial force. The layer will be moved upward, while the winding at the lower half will be moved downward. For the next slide, this is the Gantt chart. This is the progress that we make for PSM1 from the week 1 to the week 14. For the future planning, I expected to get results that just have been said before, so that I will have no problem in doing it. Besides that, I hope in PSM2 I can do this design smoothly because of I have done all of the planning and understanding all of the theory from the PSM1. And lastly, the conclusion. As for the conclusion, for this project Sarjana Modul 1, that is PSM1, a lot of research and study is being done. Therefore, in chapter 1, the objective and problem statement are being stated to get a clear vision on how to done this project. As is in chapter 2, a lot of reading and research for the article to the topic is being done. And the reason is to get more understanding on the topic that we choose. Moreover, in chapter 3, the spec or procedure is for in doing the BSM is being stated so that it can be done smoothly. Lastly, in chapter 4, the expected result from the simulation in the S of Maxwell is being shown to ensure that the real result from the simulation that will be done will get the same as the expected result. So in the future, I hope that I can make this to be I can done the simulation perfectly, because for my topic there is no hardware and I have to do the simulation correctly and get the result as what I expected. And that's all for me. If you have any question, you can email to me, or you can directly WhatsApp me or call me by this number. That's all for me. Thank you for your time, and I'm very sorry for the uh, inconvenient voice that you have been heard during this slide. That's all. Thank you.